Okay, so pretty much follows the agenda that we sent out in the emails for the meeting. So we're going to get through a couple of business items with some authorizations and approvals. And we have a presentation from the Illinois State Water Survey. We'll go over our outreach materials and wrap things up. So the first item is approving the minutes from the January 21st annual member meeting. So if anybody has any questions or comments, or if somebody would like to make a motion to approve the minutes. So I have a motion by Scott Killinger. Get a second. You can just raise your hand for a second for that motion. And I got Andrew Hawkins. Okay, can you go ahead and launch the poll?
Yeah, it's up right now.
Just let me know when you get enough.
Okay.
Okay. Thank you. Sorry, just making a few notes here. Okay, so so for the next approval that's up is for the staffing contract, which was provided in the meeting packet. Let's see. Okay, I'll keep track of that. So the staffing contract, as in the past, provides 0.925 FTE, which is about 37 hours a week, professional and support staffing. The contract was updated from last year, basically to just reflect the changes in the dollar amount. So the 71,170 is what was approved in the budget last month. And then some of the other minor changes which are highlighted in there is just really a clarification of what is covered under the billing rate. So if there are any questions, you can put them in the chat, or that was the other reason, I guess, for switching to this meeting format. If people have questions, you can go ahead and just ask them, unmute yourself and ask them. Otherwise, if I can get a motion to approve the contract, if there are no questions.
I have a question. It's Don and Shanahan.
Yeah, Don.
Okay. So on the office spaces, supplies, all that kind of stuff, it doesn't say like it's a part of it. I mean, the Conservation Foundation also like takes care of lower displays and other things, but this, at least the way I read it, sounds like 100% of this is coming from Lower DuPage.
So
the contract, or how do you reconcile that?
Yeah, so for the 30, so we have a billing rate for each staff person, and wrapped up into that billing rate is sort of like the portion of office space and the use of computers and all that, and then calculated at a rate based on like the 37 hours a week that go to the Lower DuPage. So it is really just the portion that is dedicated for Lower DuPage. So it isn't 100% of those staff, it's that portion of that staff's time associated with this group.
Okay, thanks for the clarification.
Sure. Okay, are there any other questions? Okay, can I get a motion to approve? So I have Scott and Joe Sludnick. Can you launch the poll, Leah?
Is this monitoring contracts or different?
Oh, maybe
Yeah, I only see minutes and monitoring contracts.
Okay. Shoot, I must have missed that one on the poll. And I can't go in and change that now. Let me see. Okay, you know what, we'll just, I don't have that one in here. If I can get everybody to, you may even have you could raise your hand. We could have everybody raise their hand who is in support of the contract. Or I guess, yeah, there's a yes button. Doug had it. Thank you, Doug. There's a yes button. And I can see those on this end.
I don't see that button, but I say yes.
Yeah,
Yeah, I
raise
don't see
your
that
hand.
button
Raise
either, but I
your-
raised my hand.
Yeah, raise your hand is fine.
And I just figured out how to do that, so I'm a little late to the game.
That's okay.
If you see,
Okay.
Bingo.
it's under participants. If you see participants on the bottom, click on that, and then it'll give you some options of choices.
Thank you, Doug. Sorry, I missed that one. Okay. We have the majority of you. Okay, thank you. Move on. Okay, so moving on to the negotiating staff contracts or staff authorizing staff to negotiate contracts for the monitoring. So we kind of end up in this sort of time in between meetings where we need to get this contract finalized. So we're working with NBI right now on putting together the proposal for it. We have $145,000 budgeted for the NBI portion of the contract. So they're responsible for doing the field collection of the fish, macroinvertebrates, habitat data, and then analyzing all of that field data and then the chemistry data and putting together reports. So the budgeted amount is $145,000. So and I'd like any questions about that. Otherwise, what I'm looking for is approval to authorize me to finalize that contract up to that amount. The final contract will get signed by members of the board, but basically allowing me to negotiate that contract up to the, a not to exceed amount of $145,000 that is in our budget. So if there are any questions. Okay, then can I get a motion for the authorization? I got Joe Slevnik. And Andy. Okay, thank you. And then Leah, can you launch the first question in that poll?
I think they both launch at the same time. There's not like an option.
Okay. Are they up now?
I'm launching them now.
Okay. Because then we'll come back for the second one. Then the second part of that is for the chemistry component. So we're working with the microbac laboratories again, and we actually have like a 5-year agreement on cost with them because we negotiated cost for analysis and collection in partnership with the DRCW and with the Lower Des Plaines group to basically get the best rate we could across the 3 watersheds, and that includes this year's of sampling. So really we'll be putting together an agreement with them on the number of sites and locations in that. And then the other laboratory that we'll be working with is ETP Labs out of Willow Springs to do our fecal coliform samples. Those have a very short hold time, so it's much easier to work with a local lab on that. So if there's any questions, get a motion to approve staff to basically negotiate those chemistry agreements for, not to exceed the $55,000 we have budgeted. So I have Nick and I have Scott on that. So then there's the second question in that poll that we had up. Okay. Thank you.
Ending the poll.
Thanks, Leah. Yeah, as a host, I don't see that. Okay, so we're going to move into our presentation. So we have chlorides in Northeast Illinois, connecting land use with contamination in groundwater. And we have Cecilia Cullen from the Illinois State Water Survey. So I'm going to stop sharing my screen and turn things over to Cecilia.
Thank you, Jennifer. Sounds good.
Okay, Cecilia, you should be able to share your screen.
Okay. There we go. Thank you, everyone. Thanks for having us here today. We're here to talk about chloride in Northeast Illinois, connecting land use to contamination in groundwater. I made this presentation with Devin Mannix from the Water Survey, but today Daniel Abrams, who I think a lot of you know also from the Water Survey, will be presenting this with me. So I earned my Master's of Science in Geology at the University of Illinois in 2019 and have worked at the Water Survey since then. The last year, I've been part of the team developing the model discussed in this presentation. And Devin's been at the Water Survey since he graduated at the University of Carbondale in 2013. He's interested a lot in how uncertainty affects model development and interaction with stakeholders. So our presentation has 5 parts. The first part we're going to go over is the motivation for this study. So chloride contamination can harm freshwater species, and it also increases the corrosive potential of water, which can lead to other water contamination issues. Chloride originates from many human activities, and the most impactful one of those activities in Will County is winter de-icers. The EPA secondary standard for chloride in drinking water is 250 milligrams per liter, and this is the one we're going to focus on the most in this presentation as we discuss our model results. And this is where drinking water first begins to taste salty. Other standards to watch out for are 230 milligrams per liter for chronic exposure and 860 milligrams per liter for acute exposure to chloride. So chloride enters the groundwater through many different ways. The main one that we focus on in this presentation is salt application on paved surfaces such as roads, parking lots, and commercial districts, neighborhood streets. So salt will enter the aquifer through infiltration from snowmelt or runoff or discharge. For the DuPage, I think that this presentation is relevant for the DuPage Watershed group because the chloride in the groundwater can affect chloride concentrations in the river, and chloride concentrations in the river can affect chloride concentrations in groundwater because of base flow exchange. If chloride increases to a certain amount, it can impact private wells and also affect river treatment or water treatment facilities. And when chloride concentrations increase enough in streams and lakes and rivers, it can have impacts on algal bloom, stratification, and other freshwater species. Something that we'll emphasize throughout this presentation is that road salt is not the sole chloride contributor. And this presentation will be making an effort to refer to winter deicers as salt applied on paved surfaces in the winter to prevent slipping. So in every winter in Illinois, many paved surfaces are de-iced, not just roads. And while some of these sources may be smaller inputs than others, all winter de-icers have the potential to reach the groundwater. And some of the places that we apply salt are driveways, parking lots, sidewalks, the steps to building entrances, neighborhood streets, in addition to roads and interstates. Okay, so specifically in Will County, we have 3 decades of data, and now we're going into our 4th decade of data in the 2020s. And what we see over time is that in the 1990s, chloride concentrations were at 22 milligrams per liter, pretty low. In the 2000s, they increased to 32. And then in the past decade, the 2010s, they were nearly 50 milligrams per liter. But more and more outliers are exceeding the secondary standard that's indicated by this dashed line. And the 75th percentile, of which is indicated by this block, is also getting pretty close to the secondary standard. So what this tells us, the 3 decades of data tells us, is that the mean value in chloride concentrations in the region is steadily increasing over the past 3 decades. And chloride sticks around once it's in the aquifer. And the 90th percentile is close to surpassing the secondary standard of chloride. So for the Will County trends in focus, we can observe that Will County has mixed and changing land use over time, transitioning from domestic use in natural areas to increasing commercial and industrial land use types. With the deep groundwater, with communities making decisions about their water supply sources, where in the deep groundwater, more attention is being paid to the shallow groundwater and whether that can be a sustainable sources for communities as they make their water supply decisions. And the ISWS has been working with the Southwest Water Planning Group to understand critical sources and uncertainty with chloride trends. So the model that we're presenting today has been developed with stakeholders in Will County. And from us beginning to discretize and think about this model, we would present our ideas to the community's leaders, and then we would get feedback. And from this process, we got a lot of leads that we wouldn't have thought of on our own. And it really improved our modeling process and the way we think about how chloride reaches the shallow aquifer in Will County. So our motivations in the study are to understand what causes the rise in chloride concentrations in groundwater over our 30 years of collected data. And then we want to turn to the future and estimate and understand, given the current application of de-icers and projected future application, what are chloride concentrations over the next 3 decades? And then we want to evaluate areas in Will County that our model indicates are susceptible to chloride contamination. So our model has 2 components. One is a flow component, and that's going to understand how water levels within the shallow dolomite aquifer system change with community growth through time. So that's going to be the pumping and flow in the shallow aquifer. And then our second model component is transport, and that's going to be simulating chloride transporting from the surface where it's applied down to the aquifer. And with these 2 components combined together, we have a model that's capable of simulating water levels and chloride transport. Okay, I'll turn this over to Daniel.
Thanks, Cecilia, and thanks everybody for having us here today. So what we want to now move into is the process of modeling and how comparing the data to the groundwater flow model helped us improve how we conceptualize this system. We've looked at many wells, but to simplify the story, we're going to talk about 6 specific wells throughout the area that each have some different traits to them that define how chloride has changed through time, both in terms of anthropogenic activity with land use and the geology in the region. So what you see here is where some of the major sand and gravels are located in comparison to the wells. That's a major factor, geology is, but you're going to see that there's other factors that come into play here as well. When we start the process of calibration, generally we collect water levels. And so for many of you, I know you're very, very well aware of what we've done with the sandstone in Will County, where we're matching the water levels to our model simulations. We do the same thing in the shallow. Truthfully, it's pretty insensitive to changes. We don't get major swings for a lot of these wells anyway. So we go the next level and we use chloride to help us improve our calibration. And you can see originally, while we're clustered around this 1-to-1 line, which is good, meaning that simulated and observed match fairly well, we get a lot of tells, which generally in this case are occurring where our observations are higher than our simulated values, leading to these tells that you see below. So the next step then is to run a number of different conceptualizations, both changing anthropogenic activity and changing geology to try to tighten that. And what you see on the with the current calibration plot is an improvement, a removal of a lot of those tells. Not all of them, there's still some local features there, but there is a considerable improvement as we move on a regional scale with our calibration. But we need to now look at how does this improve locally. And that's why we presented those 6 wells, because what you see is that all of these wells behave quite differently. And that's the observations. Getting the model to match those is where we need to do the local tweaks. And we'll walk through some of those later, but what you should focus on this slide are 2 things. One, how the model simulation, the black line, compares to the observations, the dots, and also how it compares to the EPA secondary standard of 250 parts per million. Most of the time, concentrations are increasing. Sometimes it's very, very small, like in E, but sometimes it's more significant. And in the case of B and D, we have concentrations both observed and simulated exceeding the secondary standard. And in the case of other wells like F, where we have concentrations that are approaching that secondary standard. So those were our current calibration, but it took a few steps to get there. And every step that we took, we learned something about the system. We had to consider land use, the anthropogenic activity, where is chloride being applied? What we actually ended up finding is we needed to increase chloride concentrations from our original assumptions on lands associated with commercial and industrial purposes. We had to decrease the applications on public roads and interstates. And talking through with stakeholders through that participatory process, this seemed to fit with the understanding that they all had of the source of chloride. In addition, we needed to refine the geology. So just land use didn't always do it. We have a model of the quaternary. It's not always perfect. There's some interpolation between points, and sometimes there may be a connection. The geology is relatively complex. The glacial geology overlying the bedrock is relatively complex. So whether there's gravel, sand, or clay makes a big difference. Using the well logs was really important to make sure we had local features captured as well as we could. And then finally, we needed to add in point sources. Land use got us part of the way, geology got us part of the way, but there were areas that still required some additional consideration. We're going to talk a lot more about point sources here. So we'll skip over some of the details on that and save that for later slides. So land use was important, and coming in, there's sort of a, call it a misnomer that has commonly been used in science when considering chloride, to just call it road salt. And that leads to an assumption that the roads really are what you need to consider when you're modeling. And that first graphic that you see with recharge 1990, recharge 2013, roads only considered the roads, considered higher concentrations on interstates, lower concentrations on smaller roads. And that was the initial assumption of the model that, as you'll see, didn't really work out very well. So what we then had to consider was land use. Where's our commercial and industrial in particular? And applying those commercial and industrial areas to the model domain, and not just applying them once, but what started to matter was the growth. So some of the CMAP land use maps, we were able to utilize and redefine our recharge zones to include land use. And you can see considerable changes when you consider 1990 to 2013 in the land use that shows up in these maps. In addition to redefining where we have recharge going in, where dark red here shows the highest recharge rates, we also had to adjust our assumed inputs. So when we started, and remember the assumption initially was, let's just get roads, that's going to be close enough. The background in this aquifer was assumed to be about 10 milligrams per liter of chloride, which is what we thought we would naturally see in the aquifer. The roads that were not interstates or that were just smaller roads, we assumed 250 parts per million and 500 parts per million for interstates. And that was that initial calibration that you saw. After we improved the calibration, the background went down somewhat, pretty insignificant to the story though. The bigger change was an order of magnitude decrease that we put on roads and interstates. And as you start to think of it, that makes sense. Our model grid cells are a half a mile on a side, and the roads that run through there, even though they're wide, are smaller than the grids. So even if some of the input concentrations are higher than 25 milligrams per liter when you take the average over the cell, then that lower value does start to make sense. As opposed to when you have more ubiquitous commercialized areas, and that's where we had to have higher chloride concentrations. And the point sources, which again, we'll talk about a little later, we actually had to put those at really high concentrations that have been observed in the literature, and we're in the process of trying to verify whether we see those kind of concentrations here in Will County, but in other areas we've seen on the orders of 1,500 milligrams per liter. So I want to walk through some of the local changes then. And we'll start in southern Will County. This is a well that was running, that has an interstate running by it. And you can see our initial concentration, that's our initial simulation. That's the dashed line. And this is the case where we're simulating too much chloride and the observations are lower. So by lowering the concentrations along the interstate, we got a much better match at this well. Here's a case where the geology mattered and the gravel in the model was not simulated enough. So we needed to add gravel after exploring some local well logs. And that gravel created a connection point from when precipitation falls and flushes chloride into the aquifer. It created that connection point for this chloride to reach the bedrock, and this is a bedrock well, and bump up those concentrations to what we had been observing. Now here's the point source story. These point sources can be many different things. They can be retention ponds that are leaking into the aquifer. They could even just be, another way to think of it is a local geologic connection that provides that conduit. But when they're not considered, the chloride concentration did not grow as much as we had seen observed. By adding in this point source in the vicinity, it elevated the chloride concentration to match the increase that we had seen, particularly at the well you're looking at here, the increase that we had seen since the year 2000. Wells B and D both required these point sources. And in general, where these are most prominent, where we needed to add these in to match the increase in chloride, was between the Des Plaines and DuPage rivers.
Okay, so our model indicates the need for these hypercharged areas of point source recharge, but what phenomenon could they be representing in reality? So this is a figure that sketches how we usually consider chloride transport. And chloride is applied as winter deicers to paved surfaces in neighborhoods in the winter. And then over time, it infiltrates through soils and the layers that overlie the bedrock aquifer. And here the bedrock aquifer is indicated by this gray unit with black stripes in it. And so over seasons and years, chloride reaches the aquifer and then infiltrate and then reaches the groundwater within the shallow dolomite aquifer. Our idea of these point source recharge concept would take place over much shorter time spans. So here's a figure, a hypothetical figure of what could be a point source area. Here it's indicated by this blue pool with chloride indicated by red in the pool. And there could be an event, maybe rainfall, and then a chloride plume would release into the aquifer. Something that we're speculating about these recharge areas is that chloride will not have to infiltrate a great deal to reach the aquifer. It'll have a pretty quick journey from where the point source is to the aquifer. So these events can happen through the year if they're triggered by rainfall and then release plumes throughout the year into the aquifer. So we're speculating at this point that point sources may hold higher concentrations and emit chloride year-round. So if point sources were affecting chloride in the groundwater in Will County, we'd expect to see that variability on smaller timescales. Most of our data that we have and our model is built to reflect decadal changes in chloride. So our question is that do we see this variability on a smaller timescale? And we're lucky enough to have data from a community in Will County that takes weekly chloride measurements from their groundwater, from their shallow aquifer wells. And what you can see in these figures is the red dashed line is indicating the EPA secondary standard. is you can see variation in chloride concentrations on a level of weeks. You can see variation in 2 weeks of over 100 milligrams per liter, which is incredible variation that we would not have thought of without this data. This also emphasizes that stakeholder collaboration is key in identifying these features and us developing this hypothesis. Another point that this variability of data brings up is, with such variability, how good of a model can you actually build that's meant to simulate yearly stress periods? So it does indicate that it's more challenge, or the variability in chloride might be even the more different than we'd expect. And a well-calibrated model would capture only the average of these points, but we'd miss the variability entirely. And to capture this variability, you'd need a smaller model that's more localized, and its time periods are on the units of days or weeks rather than years like our current model. So our ideas for these point source recharge areas could be leaky retention ponds, quarries, as that would be direct contact with the aquifer, infiltration ponds, which are specifically designed to route water to the shallow aquifer, and then leaky culverts or pipes with wastewater. While the first three proposed ideas might seem like very plausible, leaky infrastructure, I could understand some skepticism about that. And while it might be a component of overall flow, it could be locally important, especially where impervious sources would minimize natural recharge. So if you have a lot of water draining and then that's going into infrastructure, if there's a leak there, then it could potentially have a lot of chloride from that one localized place. Another thing to think about is that the more impervious surfaces you have, the higher chloride concentrations you'll have in the stormwater discharge, and where the water falling on the paved surface is routed to. So these are two aerial photos from 1997 and 2020, just to emphasize the change in land use. I know it's probably hard to parse out in the black and white photo, but you'll probably be able to see that there's a lot more fields and green areas where water would have been allowed to infiltrate and take those decades or years to reach the shallow aquifer. But now in 2020, 2021 that we're in, there's much more paved surfaces, and the water from the paved surfaces is going to drain somewhere. The inset photos are to just emphasize the increase in trucking from 1990 to 2020. That will also emphasize the need for more winter de-icers with more traffic and more paved surfaces.
Okay, and so with all of this information, both the calibration and this uncertainty of the seasonal transients in mind, we moved forward with looking at different simulations for future chloride scenarios. There were a number of these that we considered. What these maps show are the simulated chloride concentrations in 1990. Those are calibrated to both that historic data and also a previous synoptic measurement, or not synoptic, but a sampling of chloride back in 1990. 2020, of course, calibrated to the data that we were just discussing. And you can see some considerable areas where we're now over 250 parts per million. And you just saw that also in the chloride time plots as well. So the question then is, when we move forward to 2050, what can we have? There's a couple of scenarios here that you see. The first one is unrealistic, but it's valuable to know this, how this would behave if chloride was completely removed. Chloride applications were completely removed. No more chloride enters the aquifer. There would still be residual chloride in the aquifer that would not have moved out to streams, meaning that the residence time of some of the chloride in this aquifer is exceeding 30 years. That's one interesting thing. It's not unexpected. Groundwater moves slowly, and in some areas it does flush out, as you can see. Now, the other thing is we ran a simulation where we hold chloride concentrations constant out to 2050. And comparing 2020 to 2050, it's not a massive increase, but there are increases in the areas where chloride exceeds 250 parts per million. Looking at this well by well, we're going to look at some of these unique conditions. So first, let's talk about the wells that are simulated as near a point source. And probably not too big of a surprise that if that point source is removed, there's some pretty considerable changes. Remember, that's a big concentration associated with those point sources. So if it's removed, there's a pretty significant drop off, although still chloride concentrations in 2050, even if they were removed in the year 2020 completely, would be above their 2000 levels at this particular well. There's also the case of holding constant. That's the solid black line here. And what this tells us is that chloride concentrations aren't at steady state yet. So whatever the application rate is, the chloride concentrations are still growing, even if those applications stay constant. If there's management strategies to reduce them, then at this well, chloride can actually dip below the EPA secondary standard. Now we have to be careful with that because remember, there's some variability in this, but on average, we're dipping just to the secondary standard. On contrast, if there's a 25% increase in the application rate, as opposed to the decrease, then we would be bumping up considerably above that secondary standard at this well. Same thing, you can walk through it. There's a few minor details here. The main thing to point out at this well, the main difference is that unlike the previous well, this well appears to be at steady state. We've seen that with the data, and we also see it with the future simulation where if chloride concentrations are held constant, this plot plateaus. Everything else is pretty similar to, the other scenarios are pretty similar to the previous one. So that's the example of the point sources. Now the geology can change some of this. Those point sources are in an area where the sand and gravels are, they may be present, but they're often very thin. In this case, we have a thick gravel. And the interesting thing when there's a thick sand and gravel overlying bedrock is that the growth rate can be a bit slower. So there's still, urbanization in this area. There's still chloride entering the aquifer. And if there's if the application rate continues, that's going to continue up. Actually, if you completely remove chloride from this aquifer in 2020, it's going to take 10 years before the chloride concentration starts to go back down. There's that much of a lag. The groundwater is moving that slowly, which is characteristic of these aquifers. They have a lot of storage in them, which is why they're productive aquifers. And it also means that things move slowly. So it takes longer to reach steady state. This well is just at a much slower crawl than the more responsive wells we saw previously. You see something that looks similar here at well C, but it's for a different reason with the geology. Here, this is a deep bedrock well with a lot of clay overlying. So the chloride that's entering is actually much less, but you can see it's a little more responsive to that 2020 scenario where chloride is completely removed. It takes a couple of years for it to start going down, but it goes down pretty quickly. This is not that sensitive to those changes. It changes, but it's not as sensitive as the wells we saw previously. Similar story here when we move more into the rural areas of Will County, this is a deep bedrock well with a lot of clay overlying it, and the changes don't propagate that much in this well. Maybe the most important well to think about with this scenario, and I shouldn't say the most important, but something important here to consider are the wells that are right now under the secondary standard, that it's really going to matter how chloride is managed in the future, how road salt de-icers are managed, not just salt on roads. So in this case, holding things constant keeps on average below that secondary standard. Bumping up 25% increase, let's say this was an area that was urbanized more than it is now, that could bump up that increase close to the secondary standard. But management strategy, 25% decrease, gets the average level 100 parts per million below that secondary standard. So these kind of wells are really critical to step back and think about what is future land use going to be. I should clarify that none of these simulations consider changes in future land use. They just stick with the application rates as they are now and do a 25% increase or decrease. But where new urbanization can happen, commercialization can really matter in this case.
So with all this said, what can we conclude at this point? Our main conclusions that we can make from the modeling now are that land use changes have a huge impact on chloride contamination in groundwater. Not just land use, but the way that land use will change over time. From the 1990s to the 2010s, we saw that as super important to being able to calibrate this model. We've also found that small areas of high recharge that we've been referring to as point sources could have a large impact on localized contamination at certain wells. We need to do more investigation to understand what those could be. And then to make meaningful assessment of wells at risk for chloride contamination in the future, like Daniel was saying, you need an idea of future land use plans to make assessments for what future chloride contamination at wells will be. So what does this inform about our future work? We want to sample and map out landscape features that could act as conduits to the shallow aquifer. We want to use the model to guide areas where we need more data, and we're going to be starting a sampling campaign next week. And this will cover all of Will County. And I think we're going to learn a lot more from the chloride that we collect this spring and its variability across Will County. So thank you for listening to this presentation. I just want to network it on behalf of our 2 interns that have recently graduated with master's degrees in engineering. If anyone knows of opportunities that they could apply to, they are on the job market, and it's a recession right now. So any leads would be helpful for us to get in contact with them, and we can wholeheartedly recommend them. So thank you. And if you have chloride data for groundwater in Northeast Illinois that you know that we don't have, let us know. Even if you think we might have it, but you're not sure, let us know. And we'd love to hear what you think of all this and take any questions at this point. Those are our emails. Devin's not here. He helped make this presentation, but any of the 3 of us would be happy to be in contact with you. Thank you.
Thank you very much, Cecilia. Does anybody have any questions that they would like to ask Cecilia or Dan? I guess I'd had just sort of one comment. I'm going to go back to my screen up here just a second. Let's see. So just a quick question or a comment, Cecilia. So on like in the early part of your presentation, you had the slide about road salt is not the only contributor. And I think the point you were trying to make is more of that it's not it's more of the application to roads is not the only contributor. Is that really what you were getting at?
Yes, kind of what we call road salt. What people call road salt can maybe be road salt applied to parking lots, but we're emphasizing that it's salt applied to paved surfaces. Roads
Right.
are included in that.
Yeah. So maybe a way to clarify that just a little bit more is stating that a little different, because like that rock salt is kind of the major contributor to chloride in our groundwater. Because the statement, like when you first put it up there, it's like road salt is not the sole contributor. It's not so much that it's the road salt, it's you're really getting at where it's being applied to.
Okay, thank you. That's a really good clarification to make. Thank you.
Mhm. Did anybody else have any questions? Otherwise, we'll go ahead and move on with the rest of our meeting. Okay.
I'll raise my hand. Do I need to raise my hand, Jennifer? Or?
Oh, I'm sorry. Go ahead. I don't have that up. Go ahead.
Oh, that's all right. Well, I want to thank Daniel and Cecilia for taking the time here today. My name's Doug. I was just going to ask a couple of questions. One of the things, your presentation was fairly involved and it is very much focused on the groundwater aspect of it. You do mention some surface water flow and movement. And honestly, I'm more on that side of things, and I do have chloride data that I'd like to get into your hands if you're interested in what we're seeing in the river up here. I don't know if that really is your focus or if you're interested in that. So I wanted to start with that question. Do you have surface water data that you're plugging in as well? Or do you want it?
Yeah, we'd be interested in that. It's helpful for us to know the chloride concentrations in the river because that impacts the chloride that can reach the groundwater through base flow. So we'd be happy for that data too.
All right, I saw your email. I'll reach out to you on that. The other thing that I was curious about is you mentioned the concept of dissipation of the chloride content over time. And I'm wondering if you have a destination or where are you seeing the salt going? I'm just always curious about mineral deposits or mineral movement. And I would expect it comes out of the ground, but I also expect it goes essentially right back on it or in it. So is it circular, or do you actually see or expect it's all leaving the area in some manner?
Do you mean for the cases of future projections where
Yep,
if chloride was...
Yep, you had no input and a maintaining input to 2050, and in one instance the salt is depleting, and the other one it's growing marginally.
So yeah, so that was highly variable based on the geology and kind of the residence time of the groundwater at certain points. So where you have groundwater that kind of flushes out more, maybe to the river, you'll see that's where the chloride's decreasing. Daniel, you can add to that too, but that's a good question of why where chloride goes when salt stops being applied.
Yeah, I think that your question 1 and question 2 are highly related here, because one of the things that we've not calibrated the model to yet is chloride concentrations coming out during a low flow on a stream when it's going to be heavily groundwater fed, particularly thinking more DuPage River there than Des Plaines. But that's one of the things we can quantify with the model. The expectation is that it is with the model, it will be leaving either via wells or streams. And so there's that residence time then. And one of the things we can look at with that same simulation that might be interesting is how is that water kind of building up in streams through time? It'll certainly result in a decrease in streams, but we would think it would be entering into the streams during low flow. And that's something that Walt Kelly, if you've ever had a chance to talk with him, he's done some studies, but they're more in DuPage County, I think, where he's looked at base flow conditions and found a relationship between groundwater increasing and base flow in streams, and a consistent relationship between the increases seen in both of those. So long-winded way to say the model is simulating chloride is being discharged to the streams, and having data to help calibrate that better would be greatly appreciated.
And this is Tim from Strand. I just wanted to interject because I think Doug's question, and it actually was my question, if I'm hearing what Doug was saying correctly, is Doug was seeing that the concentrations were going down in one of your simulations in the groundwater when all sources were stopped. I think his question was in the crux of how is that happening? Is the soil or the material around the aquifer, is it actually filtering the chlorides out of the groundwater? Is that how it is going down? I think that was the crux of his question, is how is that change happening?
Yeah, okay, thanks for the clarification. It's being flushed out into rivers. It's actually discharging into rivers. So the groundwater has the input of recharge. The model has an input of recharge and an outflow to rivers. So that mechanism of how it's being removed, it's not absorbing, it's not decaying, it's being removed in the low flow of streams, or when groundwater is discharging to streams, and then actually leaving the watershed from that point. So that's the discharge mechanism. It can also be going into wells that are pumping. So we certainly see it going into wells. Wells pump, and then as wastewater is removed, then it could be going through that pathway as well. But generally, it's not. Nothing is happening. The model's treating it as a conservative tracer, so nothing is happening to the chloride in terms of decaying in the aquifer. Did that answer the question?
I guess it answered the hypothetical question Tim thinks I asked. So thank you for that.
Was I way off base, Doug? Sorry if I put words in your mouth.
I think that was worth asking as well. But
Okay.
I guess my last, well, who knows if it's my last, relative to surface water, because the 250 milligrams per liter that you're seeing or that you're targeting on the wells turns into I believe it's a 500 milligram per liter limit on surface water movements. And it really seems like, if I heard correct, if I understood, the escape of salt is in surface water for the most part once it's pulled out of the aquifers. I'm just curious, since essentially the salt isn't breaking down and it is just going to be cumulative, it's just a question of where is it being deposited and where is it moving the most. Do you think that 500 milligram per liter number on a surface water is a reasonable target when there's really no removal mechanism for chlorides? That's outside of your game plan, but
Yeah, it is a bit like we think mostly of groundwater. But we have read papers that talk about adverse effects to aquatic species at much lower concentrations than even 250 milligrams per liter. But with the stream water, groundwater, it takes a while for the chloride to reach it because it has to infiltrate through many different layers in Will County usually. Surface water, you usually see a spring flush, like from the winter meltwater, and then the concentrations will lower for the rest of the year is my understanding. So it's a completely different game than groundwater, where it's kind of steadily increasing in general, except these point source questions that may be allowing quicker recharge of chloride to the aquifer.
I think all in all, we're still looking at kind of the same management practices because we're dealing with the same source. So the source of, rock salt being applied to hard surfaces. And so that is, increasing chlorides in both groundwater and surface water. And so we would be looking at the same type of management practices to reduce that chloride from, to both of those, water types. And so if we're
and the systems are
reducing it,
connected too, so
Right.
that's also
if we're reducing it on the surface, we're reducing it to the surface water, which is getting there, it's getting there faster, but we should also be reducing it to the groundwater. So that means less salt going from groundwater to surface water. So although they're kind of two different systems, the work that we would be doing to reduce like application rates and implement better best management practices are going to benefit both systems. So at least we're not, we're not dealing with, well, we have to do this for groundwater and this for surface water. Anybody else have any questions for Cecilia or Dan?
I would just like to add, based on this conversation, it sounds like it would be of interest to see some model results that do the mass balance of what the model is actually simulating is discharging to streams. That would be under the low flow conditions. And that's something we'd certainly be happy to set up and share with you all.
Yeah, and we can go through some of our data from the last couple of rounds. At least we do have some summer chloride data across the watershed that we could share with you as well.
Yeah, the more data there that we can calibrate the model to, because we can calibrate on those low flows for some streams anyway, not all of them. Mm-hmm. That would be greatly valuable.
All right, I'm going to turn things over to Dina. She's going to give us some updates on just sort of the different components of where we're at for the nutrient implementation plan.
Okay, thanks, Jen. So this slide just sort of highlights the components of the nutrient implementation plan to remind you sort of what we're working on, and then I'll go through a couple of project updates. So our NIP is sort of where we're putting all of the work that we're doing. And we're looking at integrating pretty much all of our components of all of our programs that we run, from our bioassessments to our studies, into one document, and sort of making our NIP not just nutrient focused, but focused on sort of our work plan, the combined work plan between the Lower DuPage River Watershed Coalition and the DRSCW up north, and making this sort of our adaptive management plan and how we plan on and what we want to work on moving forward. So kind of the main components are the identification and prioritization system, or what we call the IPS model, which we've had a couple presentations on, and I'm not going to cover that one today because that one always takes up so much time. We're also looking at some surface water quality models, which are our Qual2 KW models, and we're looking at those for the DuPage River and the Salt Creek watersheds. It'll also look at non-point sources. If you remember back in your language that you have in your permits for the NIP, that we do have to look at not just point source inputs and management strategies for those, but also non-point source inputs. We've also been working on a trading program, because we kind of what we just based on talking about, obviously chloride reduction. We know that's a huge stressor on aquatic life in our watershed, along with the nutrients and the habitat issues. So we do want to make sure that that does not get lost and that gets incorporated into our NIP. And then we're looking at some expanded monitoring and chlorophyll A monitoring with our programmings. Next slide, please. So I'll start today with our Qual 2 KW models. We started these back in late 2019, early 2020. Unfortunately, we have not made a lot of progress on the West Branch model, mainly because we need, or the lower DuPage model, your model, because we need completion of the West Branch and the East Branch models because they form your headwater conditions. And with the West Branch, we're using our 2020 sampling data. So they're wrapping up that one. And once that one gets finished, they will go ahead and work on the lower DuPage. But we have been working on some of the preliminary setup on that. So what Qual 2K models are, these are surface water quality models. And so it's looking at a continuous model of the transport and fate of water quality parameters such as DO, temperature, nutrients, BOD, and algae in the watersheds. And what we're going to be doing with these is using these as another tool to evaluate and prioritize projects based on how they impact water quality. One of the things we've talked a little bit about that came out of the IPS model is a benchmark or watershed target of around 0.28 milligrams per liter of phosphorus for water quality as a phosphorus, like sort of a watershed phosphorus standard. And so we'd be really interested to see what does that phosphorus level that low do to the DO, as well as possibly even some of the aquatic plant life that are in our rivers, because without having a phosphorus standard in Illinois, we are really looking at how can we use nutrients to solve our DO impairments, our dissolved oxygen impairments, as well as our nuisance algae problems. And so this model will just be yet another tool in our toolbox to do that. Next slide. So what we've been working on is the setup of the lower DuPage River models to date. It'll be calibrated using your last round of sampling data, which was that 2018 data. So we do have all that water quality data. But one of the first things we need to do is sort of set up our model segments. And what we're looking at is the watershed study area, which is obviously from that confluence of the east and west branches, all the way down to just upstream of the Shanahan Dam. With that dam being a very good demarcation of the end of the watershed, we're considering everything upstream of that. So far, we've developed 21 segments. And what will happen here is that you can think of these segments as independent models. So everything within that segment will sort of be modeled the same, and then it'll go to the next segment, all the way downstream. And we sort of broke these segments by looking at the locations of the dams, the inputs of major tributaries, major road crossings, and where the IEP reach segments break. We also took into account things such as the POTW locations, land use changes, and other things like that. But sort of for your watershed, these were our major ones. They're really good in length. We range from about 0.1 miles to almost just under 4 miles for the various segments, which should give us a really good coverage and really good opportunities to run some really neat scenarios with this model. And there's a map of each of those segments on that side. I also have a memo that sort of details all of those. So we can get that shared if you are interested. Next slide. And here's just sort of a summary of all the data that we've used in the model setup. We won't go through it all, but we're using sort of all the data that we can get our hands on. Obviously, all the continuous DO monitoring that you guys as partners have been doing in the watershed, all the bioassessment data from that 2018 survey will be used. The HECRAS model that the Corps of Engineers developed as part of that DuPage, East Branch, Lower DuPage feasibility study was super helpful for setting up hydraulics. We need meteorology data, we need all the point source data, and all that water quality data. So this is sort of what we've been working on in terms of that DuPage, is setting up those segments, making sure we have enough data so where we can select our priority calibration scenarios and getting all the data formatted and inputted. And then as soon as that West Branch model is complete, which should be happening, if it has not happened already, I have not talked to my contractors since early in March. I have a meeting with them in 2 weeks. Once that gets done, we will go ahead and calibrate and set up and get those out to you guys. We're hoping to have a really detailed presentation about the setup, the calibration, and even hopefully some sensitivity analysis at our next meeting in May. That is our target date for that work. Next slide. So that's all I had on the Qual 2KW model, since a lot of the exciting work has yet to happen yet. But we did want to bring up that how we're looking at non-point sources. We haven't talked a lot about this with the lower DuPage, but this sort of has been an ongoing work with the projects committee, with the DRCW projects committee that does have many representatives from the lower DuPage on it. We sort of have integrated and have this one project committee for the both groups. And what we've known is we've been funding, the DRCW has been funding some work out of Wisconsin with the USGS looking at leaf litter, and leaf litter has been identified and confirmed as sort of the major source of dissolved phosphorus in urban areas. So with that being such a major source of phosphorus in our streams, what can we do to help reduce phosphorus inputs? And so we are looking at coming up with sort of a survey to find out what practices are out there. What are our communities doing, and not just in terms of leaf litter, but also street sweeping, which is a complementary practice or can be a complementary practice to leaf litter pickup, as well as vector waste. And we've been working on some survey language, and we've discussed it in detail at our last projects meeting. We need to revise the survey a little bit. But what we're hoping to pull out of that is sort of how much leaf litter are we already removing in our watershed? So we get credit for that. Like, we are already removing this huge source of phosphorus in our watershed with our leaf litter programs. Can we quantify that? And then are there any opportunities for improvement? We don't know, but it'd be something that we want to look at, because once again, the NIP has to identify not only the sources, but also provide any solutions if there are opportunities for improvement. And another way we're hoping to also look at this and maybe even do some pilot projects is we've have this developed this intersection of canopy. The Morton Arboretum has this really amazing GIS layer of canopy and tree cover down to exactly, you know, what kind of trees are there. And we're sort of looking at that intersecting with the transportation network to sort of identify where there might be some high areas for leaf litter to be in the streets, and then correlating that to what practices are being done in those areas. And I want to give V3 a shout out. They had some work. They had a GIS tech that had some work availability during the early pandemic closures, and they gave us a lot of pro bono work to help us develop this layer that we'll be using for this assessment. Next slide, please. The nutrient trading's been sort of on hold, and we've talked about it a couple of times, and I keep just telling you that it's on hold, but we are making progress. So what I have up here is sort of the final part of our point-to-point source program. That's been done in since 2019. We sort of do know that we do potentially have some feasibility for phosphorus trading between our wastewater treatment plants at sort of all the levels of treatment. Obviously, the lower we treat to, whether we go that 0.5 or that 0.1 milligram per liter of phosphorus does get lower, those opportunities obviously increase. And since we are not to those levels, we don't know if we need trading. We don't know if we need documents to, you know, help two plants negotiate a sale and a buy. We sort of have put that on hold until we figure out where we're going to end up with a phosphorus limit, whether we're going to use something from our NIP or take something like the NSAC, which is the 0.1, or, you know, there's, you know, or existing 1/0.5, depending on where you are in the plant and with your permitting. And, you know, we need to know what that final number is before we can negotiate or move forward with the point source program. The second part of that analysis is we really want to look at stream restoration crediting. And we've been waiting for the IPS model because we need some sort of tool to sort of evaluate and put a credit, assign a value to our in-stream projects, to our stream restoration projects that include habitat improvements and bank stabilizations and fish passage. How do we assign a value to those? And we really wanted to try to use that IPS model because we have a model that's out there. Why develop another one if this tool would work? And we've spent the last part of 2020 putting both our trading team together, which is made up of Tetra Tech and Kaiser and Associates, with our IPS consultant, which is MBI, and putting them in the same room over a couple of, same Zoom, I guess. I'm putting them and having them ask questions and debate. And we think we have a path moving forward. However, what we need to do to actually make that work is a significant increase in scope to the project. And our projects committee it is actually a huge increase in cost to the project, that we do have the monies in the budget that we could do if we wanted to move forward. But what we want to make sure is we want to go back and talk to our wastewater treatment plant operators who would be the ones that would be using this trading to see if it's still a concern. Way back in 2018, the costs that the plants were looking at to treat to phosphorus, especially at this low levels for some plants, was very high, and they wanted trading as an option, as a way of getting to that permit limit. Things have changed with technologies, feelings have changed. We sort of have adapted, where are we at 3 years later now? And it may not be so scary, and there may not be any need to go ahead and invest, another $100,000 or so into an effort, because we won't need it in the end to actually meet our permit requirements. So we're pulling our special condition permit holders, which are our wastewater treatment plants, together into a room to not only discuss this trading, but sort of our path forward and where we're at. Excuse me, I'm gonna cough here. Moving forward and where we are going with this before we, invest those resources. So if you are a wastewater treatment plant operator, expect a email from us here, hopefully, if not tomorrow, early next week, with some options for dates for this meeting. What I think we're looking at doing is, because we can meet in small groups and some of this discussion is very hard to have over Zoom, we are going to be proposing to do watershed specific meetings. So we would look to have a lower DuPage meeting of the permit holders, in a space where we can socially distance and wear masks. And if people are comfortable doing that, we will do that. We'll also offer an electronic a Zoom online version for those who can't. And then, the East Branch, the West Branch, and Salt Creek will have them. This is more of like, not just us talking at you. We really want to have a very good discussion. And sometimes some of that gets lost in Zoom. So we're going to try to do it in these smaller meetings, socially distanced, masked, if people are comfortable with that. Next slide, please. The last thing I'm going to talk a little bit about is our expanded DO monitoring program. If you remember back to the NSAC, a lot of that phosphorus work was tied to having chlorophyll A sestonic, which is the in-water column chlorophyll A, as well as benthic chlorophyll A data. And benthic chlorophyll A is the algae that grows on the rocks and the substrate in the streams. And this was something that we did not have. It was not part of our bioassessment program. We sampled a lot of nutrients and metals and organics as part of our water chemistry side, as part of those bioassessments, but not chlorophyll A. So one of the first things we did is we made chlorophyll A a nutrient and demand parameter. So now at all of our bioassessment sites throughout the 4 sub-watersheds, it is collected every time a nutrient demand sample is collected. So we're getting multiple pools of chlorophyll A at each of these locations during the bioassessment year. We're also very interested in trying to figure out, we know that there's a lot of complex interactions on what is impacting dissolved oxygen, as well as how phosphorus expresses itself at sites. So we kind of come up with this program to sort of get key locations where we can get a better idea picture of what is going on. Is the low DO caused by something like the lack of riffles and pools and the water is not getting oxygen? It's just shallow, slow moving and slow. Or is it being driven by a biological force? And this program is sort of aimed at trying to get to the bottom of that. So we're putting out sondes. We have separate sondes that are in addition to the normal continuous sondes that our partners, Plainfield and Naperville, and then downstream have put in each summer. And we're putting in these sondes. They're out for about a week. And while they're out, we come out once during that time frame and we pull this very complex side of water quality parameters you can see there. Some of them are part of the bioassessments, others, especially the dissolved, the orthophosphorus, the total dissolved phosphorus, dissolved carbon, things like that, VSS are not included in our bioassessments. So it's helping us kind of get a complete picture. While we're out there, we're also doing a cross section and taking flow measurements so we can kind of look at some of the loadings and what that stream looks like. We're evaluating shade and riparian cover, and we're taking benthic chlorophyll A samples. And this is happening. What we're doing is we're doing it at all the headwater locations on these streams. So it would be your headwaters is pretty much your upper reach. We do it below every one of the wastewater treatment plants and sort of on the major tribs to kind of get a big picture of what's going on. And so this will be done in conjunction with the 2021 lower DuPage sample sampling that Jennifer had talked about earlier in the meeting with that bioassessment. So our labs, field crews, and MBI are doing the bioassessment, and our staff at TCF, led by Alex Handel, is going out and collecting this data. So this year will be really busy. We're not only doing Salt Creek in the lower DuPage within within the confines of this NIP, but we also are doing some lower desplane sites too. So if you're looking for us this summer, look in your nearest stream, and that's likely where we'll be. I think that's all I had, Jen, for my slide.
Yeah, yep, that's it.
So
Thank you very much, Dina. If anybody has any questions, feel free to just go ahead and ask. Or if you think of something, send me an email or send Dina an email. We're happy to.
I have a question. This is Tim from
Yeah.
Strand.
Mhm.
I'm curious on the leaf litter, the phosphorus spike from the leaf litter.
Yep.
So was this area not as treed previously? I'm trying to understand, because if there were more trees here historically, wouldn't the phosphorus concentration in the stream have been higher pre-development when this area was completely forested over?
Yeah, but then they also allow those trees to not have a direct connection to the streams like they do now. You know, your storm sewers may go into a detention basin, and then, but you have to remember, we're looking at dissolved phosphorus here. So a lot of dissolved phosphorus is not being removed through the detention basin. So what happens is you get those big first flushes out of the streams with those big spring rains when the detention basins discharge into our rivers and streams. So, you know, we've kind of created this pipeline where everything gets funneled into one place and then comes out as a hotspot, where when we were natural, you had some that was infiltrated into the ground, and then it was used for plant uptake and, you know, used to grow more trees and more understory. And now we've sort of broken that network.
So is the spike in the fall when the leaves are falling, or in the
So they're
spring?
actually seeing two spikes, and this is something that we're actually trying to dive into a little bit more. There is in the fall, but there is also some big sites in those spring rains, which we think are from sort of those detention basins. We're seeing, you know, we don't have a lot of dissolved phosphorus data in our streams, but one of the things that, as we're diving more, especially into these Qual2 models that is focused on dissolved oxygen, we have a lot of streams that where they're breaking their DO standard is not when you would think, you know, when you think historically with dissolved oxygen, you're thinking low flow, hot summer conditions that give you those big DO swings, right? You get that benthic algae in the chlorophyll A, you know, throws it way up in the evening, and then during the day, sorry. And then in the evening when it's dark, we get those huge crashes. You think you get those big cycles, and that's where you historically see DO impairments. In our streams, we're actually seeing them in May. So where are they coming from? What is causing that? And this is sort of what we're trying to dig into. Is it coming from those spring rains that are flushing, you know, basins after the winter? You know, what is driving that? I sort of went off on a little tangent, so I don't know if I answered your question.
Yeah, you did. Thank you.
Okay. But it's been super interesting. We've really, with the calibration of the West Branch model, all of our sites on the West Branch meet the dissolved oxygen standard year after year after year, starting in like mid-June all the way through the summer, which is where you expect to see those huge DO fluxes. But then you look at early May through that early June period, and that's where we're seeing those exceedances. So that's a separate issue where we are trying to get to the bottom of that. But one of the things it could be tied to is some of these inputs coming out of our storm systems.
All right, any other questions for Dina? Okay, I think we'll move ahead to get wrapped up. I left this slide in from the last time. Things are pretty much still in about the same place that they were in January. Forest Preserve District staff are working with the State Historic Preservation Office on just sort of, basically we want to be able to dewater the dam, take the photographs to document the structure of it for the report that we need to complete. But that photographing needs to happen, and then hopefully we'll just get our permits to take the dam out at that point. So that's kind of where things are at in the process, but we're just waiting for low flows to get moving on that. I'm gonna turn things over to Leah for this last section, just given kind of an overview of where we're at on our outreach materials.
Yeah, so I'll just take a few minutes to let you know the new materials we have. So we're ahead of the game. So we have our spring and summer materials ready. And so the thought is that this gives you and your communications staff plenty of time to just plan out how you want to use them and integrate them into your social media schedule or newsletter. So you can find those on our website, which is what's shown here. And then if you, from that seasonal campaigns page, you'll see the different seasons it's broken up into right now. So spring and summer. And then our topics for spring and summer. So we have new materials, but our past materials are equally great. So we have a lot on rain barrels, rain gardens, and talking about just stormwater management, what residents can do on their properties, and also things on detention basins for HOAs, and then a lot about native plants. And then we have our pet waste campaign that we're relaunching, and then a new materials on river recreation. So some of our new topics are on creating a rain garden, like a more detailed guide, ecology on freshwater mussels and how they help clean the water in our rivers and streams. And then we are doing a year-long project, which I'll talk a little bit more about, called Garden Refresh, which will be kind of like a model of what residents can do at home in terms of native landscaping. And then a topic on river recreation and how we can be responsible and respectful. And then more things on rain barrels. And then we have our pet waste campaign. So I'll give you like a couple examples of some of those resources. So we always have these little social media graphics in the spring, again, just things on rain gardens and native plants. And then I think I have some highlighted past materials on the next slide. So again, more on rain gardens, rain barrels, and then I just wanted to highlight that we have these guides. So if any of you are doing a rain barrel sale in your community, we have a FAQ guide, which is really great. When residents ask questions, or you can just share this directly with them on your website or something like that. And then also a native landscaping how-to guide. And then next slide. So a little more about this garden refresh project we're doing. So throughout this year, we are at our office at the McDonald Farm in Naperville. We are going to show the process of creating a native plant garden from start to finish. So we really like to encourage planting native flowers and grasses and trees to help infiltrate that stormwater into the ground and reduce stormwater runoff. So we're just going to show and give examples of how residents can choose the native plants that will thrive on their properties, tips about landscape design, how you would prep your beds, and how you plant and maintain them. Because we want to kind of capture a bigger audience, not just people that are already know about native plants, but maybe people who have a traditional garden and could integrate native plants into that. And then so some of those resources will be like blogs, social media posts, videos, and webinars. We have our first webinars in a couple weeks, and it's going to be about the design aspect of designing a native plant garden. And so we already have some blogs available, but they'll be like more just releasing throughout the year that I will share with your communications staff. And then highlight our new summer material, which is talking about responsible river recreation. Some communities have had problems with just people not being respectful, being loud, littering when they're on the river. So we have this poster or infographic to share, as well as social media posters, smaller graphics that break it down into each kind of tip.
And if there would be interest from those communities along the river in kind of turning the poster into a sign, we can definitely work with communities on that. The company that we use to do the pet waste signs is really pretty reasonable and had a very quick turnaround. So if that's something that communities would be interested and being able to, post along canoe launches or things like that, definitely reach out to us on that.
Yeah, and if this goes for this resource or any resource, if there's a specific tip suggestion here that's not on here, but really you need that for your community because certain people are recreating on the river in a way that you don't like, so you need like a custom tip, you can also let me know, and I could kind of modify that for you so it can be more relevant. And then probably know by now, but we have this pet waste campaign and we are kind of relaunching it in May as more people get out and enjoy our parks and preserves. So in May, we will be posting once a week. We have a whole stash of all these graphics, some of which are on the side. And so our hope is that if we all kind of post in May, we'll get the kind of a cohesive, consistent message out there and encourage homeowners and dog owners to scoop the poop. So also we still have signs and dog waste dispensers and extra bags available. So if you would like to participate in our campaign and get these free materials, just contact myself or Jennifer.
And we've been working with municipalities, with park districts. We've even had some homeowner associations that have trails, through their common areas approach us. So we're willing and interested in working with anybody who would like to get the signs or dispensers. So just, reach out to us and let us know.
And then just a reminder, we have a Facebook page so you can kind of see examples of what we're doing and you can share our posts directly from there. So here's just an example of like how we used one of our social media posts. And then the next slide, we'll also share other resources. So the Conservation Foundation does these weekly webinars, some of which are very relevant to us in the watershed issues. So you can see some of those on there. And I think, then there's also we have a lot of past ones on our YouTube page, the Conservation Foundation's YouTube page. You can find those there. And then I also, on my email list, which has a lot of your communications staff, I kind of just highlight some of those relevant webinars every now and then. I think that's it.
Yep, that was it. Yep. So that kind of gets us to the end. Let's see, I do have a question in the chat. And Don, I don't know if you want to go in a little more detail. You asked about if I skipped something regarding the NPDES permits. I'm not sure where that was supposed to be.
It's on the agenda as number 8, says 2021 NPDES permits.
Oh, okay, I'm sorry. Yep. Let me go back here. Somehow I ended my. Really, I think in general things have been in somewhat of a. We're waiting. So our language for our dischargers, the special conditions language, is shared between the DRCW and the Lower DuPage group. And there's, Dina had mentioned extending that language for another permit cycle. And so we've been in contact with permit holders that discharge into the DuPage on that language. And we're waiting to hear back from US EPA and Illinois EPA that they're comfortable with extending that language. And so it would basically, again, push out meeting the 1.0 out another permit cycle. And then in return, there'll be additional funds for restoration. So we'll be either expanding projects, sites that we're designing for, or would potentially add another project site onto our part of the watershed restoration projects. And DRCW has also identified other projects that they would do with those additional funds. So all of the permits right now are are being held until that language has been approved. So I know we have a few plants whose permits would be out right now, but they're being held at Illinois EPA until the language is finalized. Okay, is there any other questions? Otherwise, I think we've wrapped up everything.
Jennifer, will you guys be sending out MS4 materials from the previous year as you have in
Yes.
years past?
Yes, I will have those out before the end of March.
Okay, thank you.
Jen, can I just mention one last thing?
Yes, please.
So just don't forget, so, I mean, we're taking care of it, but just so you guys know that per your special condition permits, an annual report on our activities and the chloride management is due to the IEPA by the end of this month, March 31st. I don't know how many days there are in March. And so staff is working on that right now, and we will meet that deadline. So when we submit that on your behalf, so the IEPA does not want to get 30 emails with the report attached. So staff will submit that report to the IEPA, and we will make sure that each of you guys have a copy for your files when that's finished. But just in case that comes up on your radar or you hear about it, we are working on it and we will meet that deadline.
Any other questions or comments from anyone? All right. Well, thank you all for joining us today, and we will be in touch with the various reports and things going forward. And then our next meeting is May 20th. So I'm going to get that in your calendars, and I think we'll continue on with the more of the meeting type format. Just makes it easier for people to ask questions in that versus the webinar format that we'd used in the past. So thank you all, and enjoy the rest of your day.